Okay, here's our video on fixing scientific notation. So what does that mean? Sometimes you have numbers that look like they're in scientific notation, like the top number here. It looks like it's in scientific notation, has powers of 10, but it's not in scientific notation. It's a good number, right? People can use this number, and you'll get this answer here. You get 23,400. Scientific notation, remember, the decimal comes after the first number. So we have to fix this. This is not in scientific notation. So this is in scientific notation. So I move the decimal back to here. And remember, if we move it back now, we have to change the exponents. So this is the number we're trying to get. So if we move this 3 times, 1, 2, 3, we would get this number. We want to get the same number now. If I moved it back, it's like taking a step backwards, right? So now you have to add an exponent. And you can always check. Just think, if you have the decimal here, if you moved it 1, 2, 3, 4 spaces, you'll get the same number. Okay, so remember, in scientific notation, the decimal has to come after the first number. And then you have to change the exponents. Okay? Let's see if you can do this problem. See if you can do that. Now, it's not in scientific notation. Why? The decimal has to go here. So it's 3.56 times 10 to what power? What power do you think? Now, 10 to the 0 power means what? It means 1. So the answer here, this answer right here, is just 0.356. So how can we get this same answer here? We need to move it back 1. And to move it back 1, we need a negative 1. Negative 1 would give us the same answer. Okay, so let's try this one now. Pause the tape and try to do that one. Okay. Now again, with all these numbers, they're perfectly good numbers. They're just not in scientific notation. So in scientific notation, we put in 9. We put the first number, which is 9. Now we don't have to put 0.0. We don't have to do that. You could just write 9. Or if you want, you can put 0.0. It's 9 times 10. Now, how can we get... Well, let's find out what this number is first. Well, this is saying go back 3. So this is saying 1, 2. It's going back 3. You're adding more numbers. Let's do that over here. So it's 0.000009, right? 1, 2, 3, 4, 5 zeros. Times 10 to the negative 3. And when you have a negative 3, you go backwards. So this is saying from here, go 1, 2, 3. So we should have this many zeros. Our answer, put those 5 zeros back. So we should have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. So this is the answer we're trying to get. How can we get this answer in scientific notation? Move that over. We want to move, now the decimal's here now, even though, right here, see the decimal's right here. So we need to move this back. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We need to move this back 9, so it'll be a negative 9. Okay, let's double check this. Again, this was the original question. We had 1, 2, 3, 4, 5 zeros. We'll end up moving it back 3 more zeros, right? Because the decimal is right there. So we would have 8 zeros. 8 zeros after the 9, and the decimal is right after the 9 there. So we have to move this back 1 and then 8 more. So that's why we got 9. Okay. Let's look at another one. What if we had a division symbol? When you see division, think of the opposite of multiplication. Whatever you would do with multiplication, do the opposite in division. So let's look at here. This is saying 2.3 divided by 10 to the third power. If it was 2.3 times 10 to the third power, we would move this 3 times to the right. But if it's division, we do the opposite. Now we have to move it 3 times to the left. 1, 2, 3, and we would get this number. Keep that in mind when you see a division symbol. Do the opposite you would do with multiplication. Okay, so what about this? Try that with the division sign. Remember, in multiplication, a -2 means to go back two times, and we'll get 0.034. But in division, we do the opposite. So now we move it this way, and we'll get 340. So remember, in fixing scientific notation, we want to make sure that the decimal is right after the first number. And with division, make sure that you do the opposite you would do with multiplication. Okay, great job.